So we're starting a brand new unit. This is on volume, surface area, and a bunch of stuff to do with 3D figures. So today we're going to do the volume of a rectangular prism. So the volume of the 3D figure is the amount of space inside the figure. This is different from surface area, which we will get to, because surface area is the area of all the faces on the outside. So we want to find the space on the inside. So think of like, I don't know, a tissue box or a package or even like your cell phone. We want to find the space inside of it. So that's called the volume. It's extremely easy to do because it's a three-dimensional figure. You have 3 dimensions, length, width, and height. All you need to do is multiply the 3 together. And because you're multiplying 3 dimensions, you put a 3 over your label. So let's try this one. I'm going to add some numbers to this so that we can do it. So let's say that this height is 10 meters. And this width is 3 meters. And this length is 12 meters. This obviously isn't drawn to scale, I'm just making up numbers. So to find the volume, all you need to do is multiply the 3 numbers together. You can multiply them whatever you want, whatever order you want, it doesn't really matter. So I'm going to do 10 times 12 first. So just because I know that any times you're multiplying something by 10, you're literally just putting a 0 at the end. So that's 120. Then I'm going to just go ahead and multiply that by 3, the final number. So 0, 6, 3. So 360 meters cubed this time. Cubic meters, you put a 3 over it because it's a 3-dimensional figure. So literally all you're doing is multiplying the 3 numbers that they gave you and putting a 3 over the label, and that's your volume. So that means that that's how much space is in the inside of that 3D figure. Sometimes you get one like the one I'm going to do here, where you have to find a missing dimension. This is where equations come into play. So let's say, I'm just going to try to do numbers that aren't too bad here. Let's say that this is 5, this is 4, and this is x. We don't know what this is. But let's say we're given the volume. They're telling us what the volume is. So let's say the volume is 100 meters cubed. Okay? So we're given that the volume is 100 meters cubed, but we don't know what the width is. We have the length and the height, but we don't have the width. So we have to find that missing measurement. So we know what the formula is: length times width times height. So I'm going to try to put a big X there so we can differentiate. So we know that when we do length times width times height, we need to get 100 because that's what it tells us the volume is. The volume is 100. So I'm going to simplify this a little bit. I know that 5 times 4 is 20. So I'm going to replace it as 20 times something, the missing measurement, has to give us 100. Now we have a one-step equation, which we've done before. So you find the equal sign, find the side with the variable, and do the opposite. They're multiplying by 20, so we're going to divide by 20. So I write it on both sides of the equation. And then the side that has the variable, they're going to disappear. So I get x equals 100 divided by 20, which is 5. So our missing measurement was also 5. So clearly this is not drawn to scale. I just picked numbers that would make it work because clearly this is not the same length as this. I just picked numbers that would make it work pretty for us. So if you have 2 out of the 3 dimensions, you would multiply those 2 dimensions that you did get together and write it as an equation and then solve the equation. This is one that we could clearly do the math in our head, but you might get ones that have decimals or fractions. So that is, I wanted to show you like the actual steps. So when you have harder ones, you know how to do it. Okay, so volume in general, multiply the 3 numbers together, put the label, put a 3 over it. If you're finding the missing dimension, multiply the 2 that they did give you, like in this case 5 times 4, and simplify it to whatever you got times the missing measurement equals whatever the volume is. Then solve it just like you would an equation, and that gives you the missing measurement. Okay, so I'm going to do some on the big ideas for you to try.